Alright everybody, this is a review lesson of multiplying fractions to a whole number. So we're going to use some models in this, and then we're going to also review how to do it if you don't have a model and you just have a fraction and a whole number. So with that, I'm going to jump right in to kind of show you how to solve these problems. So let's look at this problem right here. As you can see, we have some triangles here, and half of the triangle is shaded. So the first thing I'm going to look at is the fact that only half of that triangle, of all of the triangles, are shaded. So I know that I'm going to be dealing with the fraction of 1/2. But now I have to look at how many models there are in all. And I can count 1, 2, 3, 4, 5. So I know that I'm going to be multiplying 1/2 times 5. Now, whenever I multiply a fraction by a whole number, what I do is I put the whole number over 1, because there's an understood 1 here. Okay? And then I just simply multiply straight across. I know 1 times 5 is 5, and then I know 2 times 1 is 2. But there's something wrong with this fraction. It's improper. So I need to change it to a mixed number. So I have to ask myself, how many times can 2 go into 5? Or rather, if you want to flip it on its side, you would be looking at a division problem, which is 5 divided by 2. How many times can 2 go into 5 equally? Well, I know 2 times 1 is 2. I know 2 times 2 is 4. I know 2 times 3 is 6. Well, it can't be 3 because that's above my number 5. It's bigger than 5. So I know that 2 can go into 5 a total of 2 times. So 2 times 2 gives me 4. And in order to get to 5, I know I have to go up the number line one more number. So I know there's one number in between 4 and 5. Or you could subtract 5 minus 4, which would get you 1. And then I keep my denominator. So my product here is 2.5. Okay. Now I could also do this another way by looking at the models, and I could shade in a total of 5. So, and when I do that, I'm going to have 2 wholes and 1/2 left over. So basically, this is repeated addition. 1/2 is already shaded. Here's another half. That makes 2 halves. Here's 3 halves. The yellow would be 4, and then I have 1/2 left over. So as you can see, I have 2 holes that are filled in, and then 1/2 left over. So this is my mixed number, 2.5. All right, so let's look at this one. I want you to use this model, or we're going to use this model, rather, to solve a problem. So if you think of fractions, we deal with rows and we deal with columns. So how many rows do I have? Rows go side to side. So, and columns go up and down. So this is a row, these are my columns. So if I count, I've got 1, 2, 3, 4, 5. I've got 5 rows total. And then my columns, I've got 3 columns total. These two numbers are my denominator of the fraction. And when I multiply, let's say that let's say 2 rows are shaded. I'm creating this problem as we go. So 2 rows are shaded here. And let's say that our problem says that 1 column is shaded. So basically what this tells me is that I've got 1/3 shaded, which is represented with the yellow. And then I've got 2/5 shaded, because I've got 2 of 5 rows shaded. Now, when I multiply these, what overlaps is going to be my product out of the total number of units. So I can see that there are 2 units here that are overlapped and shaded both blue and yellow. So I know that my numerator is going to be 2, and my denominator is going to be the total number of units in all. And I know 5 times 3 is 15, so that would be 2/15. And if I did this just the standard way by just multiplying top and bottom, I know 1 times 2 is 2, 3 times 5 is 15, and so this would be my product. All right, let's look at another one. Here's another one with models represented. So I need to ask myself how many units are shaded in each square. Well, 1 unit is shaded in each square, and it's out of 4 because there's 4 total units. And I'm multiplying by the number of models I see, or number of squares. So 1, 2, 3, 4, 5, 6. So I know 6 is going to be my whole number. And when I do this, I remember that when I'm multiplying by a whole number, all I've got to do is put that 6 over 1, and I create a fraction. And then I can multiply across the top and across the bottom. So 1 times 6 is 6. 4 times 1 is 4. But I have an improper fraction here, so I need to create a mixed number or see if I can get a whole number out of this. So in order to do that, I've got to basically look at it as a division problem, 6 divided by 4. How many times can 4 go into 6 equally? Well, I know 4 times 1 is 4. 4 times 2 is 8. It can't be 2 because the product is 8, and that's bigger than 6. So we know that 4 can be multiplied by 1 to get 4. So I know I'm going to have a whole number of 1. And then I need to know the difference between my numerator and that 4, which is 2, and I keep the denominator, which is 4. Now, you can leave it like this because our standard does not talk about reducing or simplifying. So this is correct, but if you wanted to go a step further, you could reduce this by dividing the fraction by 2. And when I do that, I get 1 and 1/2. And so if I want to double check myself, I can go up here and I can shade in a total of 6 squares and see where I end up. So I've got 1 shaded already. So here's 2, here's 3, here's 4, here's 5, and here's 6. So, 6 was already done for me. Let me back up. So 6. So if you look at the model, I have 1 hole that's filled, which is here. And then I've got 2 of 4 here. So 1 and 2/4 is my mixed number, or if you simplified it, it'd be 1 1/2. All right? So now if I give you a couple of problems when we're talking about multiplying by a whole number, get my pen back, and say I have 4 times 1/3. All I do is I put this 4 over 1, and I simply multiply on the top and the bottom. 4 times 1 is 4. 3 times 1 is 3. Well, this is an improper fraction, so I have to change it to a mixed number. 3 can go into 4 one time, because I'm going to multiply by 1 and get 3. So 1 is my whole number. I have 1 left over to get to 4, and then I keep the denominator. So basically just put that whole number over 1 and then multiply straight across. If you need extra practice, you can, in your take-home workbook, or the skinny workbook as I like to call it, because it's a lot skinnier than a math book, if you look at 8-1, it will give you some extra practice problems that you can do. And if you have any questions, you can then bring those into class. All right, I hope this helps.